I have to use mathematical induction to show this relationship. 3 to the power n is greater than equals to 2 to the power n plus 1 for n all integers greater than equal to 1. So I will use mathematical induction. So first I will do it for n is equal to 1, which is the first possible value. So when n is equal to 1, left hand side, let me say, I don't know, 3 to the power n, that becomes 3 to the power 1 is equal to 3. And this one, right hand side, is 2 to the power 1 plus 1, which is 3. So that's actually equals to, so that actually satisfies our relation there. So it's equals to, not greater than but equals to, that's fine. Now we assume that when n is equal to k, any arbitrary value, this relationship holds. So we can say when n is equal to k, 3 to the power k is greater than equals to 2 to the power k plus k. Once we do that, from there, using this relationship, we move on to show what happens when n is equal to k plus 1. If we can show that this relationship holds for n is equal to k plus 1, then we have proved the relationship basically. So when n is equal to k plus 1, the left side becomes 3 to the power k plus 1, which is basically 3 to the power k times 3. Now this one can be written as 3 to the power k plus 3 to the power k plus 3 to the power k. I will just write like that for the time being. And the right hand side becomes 2 to the power k plus 2 to the power k plus 1 plus k plus 1, because that one was 2 to the power n plus n. So this one can be written as 2 times 2 to the power k plus 1 there. So this is becoming 2 to the power k plus there is another 2 to the power k plus 1. Now we have assumed here that 3 to the power k is greater than this one. So basically here we have 1 3 to the power k. That one is greater than this whole part. And then we have another 3 to the power k, which is, of course, k is not 1. Here we have 2 to the power k plus 1. But our k is not 1, it is greater than 1 now, because it's k to the power k plus 1 basically. K is not 1 actually, because we are doing for any integer k above 1. So this one is already has to be greater than this part, and we have additional 3 to the power k there. So we can say that this one, we have shown that it's actually showing that this side, this one is greater than this one. So basically when n is equal to k plus 1, 3 to the power n is greater than equals to, so the relationship, basic relationship, is greater than equals to, or we are seeing that it's actually greater than, so 2 to the power n plus n. So that's true. So we have proved the relationship using mathematical induction.